Hello everyone, welcome back again. So previously we had covered how to identify the Log4j package in an SBOM using SIFT, using Anchore CTL, and how to identify that vulnerability using gripe in Anchore CTL. Today we're going to talk about how that works in the enterprise product and additional coverage and visibility you get within the enterprise product to quickly triage the Log4j vulnerability. So I'm going to go ahead and dig into an image analysis here, and I'm going to select an image that I know has the Log4j vulnerability. So I'll just jar. Let's see. So we'll dig in here, select this image. And when we were working in the API and working with CTL and SIFT, we noticed that we were generating an SBOM. In the UI, this is what that SBOM looks like. So we can go in here and we can look for that Log4j package quite easily. Similar to how we were just using grep to identify it, we were able to gather that query very easily here in the UI. So we can see that package is there. You can also see a build summary of how that package ended up in that image. And then we can come here to the vulnerabilities tab. And this is very important if you're working in any incident response type of role. So the first thing that, the best practice and guidance here is to identify external facing internet assets that do have the Log4j package installed on the system, right? And also, right, you don't want to just limit your response to only external facing stuff. You want to focus and double down on the internal facing applications that you may have too that are leveraging Log4j. So in order to identify those assets, you want to be able to query for this specific identifier. So if I filter here, I can view the images that are impacted by the Log4j vulnerability with a click of a button. So I was able to identify that this vulnerability was in this image, and then from there all I had to do was click the button that said view other images impacted by this vulnerability. So this is very useful. So now I have an inventory list of all the images that share that same CVE, and you're able to query that CVE at any point in time here in the vulnerability ID. So you can go ahead and generate a report based on any of the Log4j CVEs, not just the first one, but also the second and third disclosures that were made in recent days. So as of right now, on December 21st, as I make this video, you should be patching to Apache Log4j 2.17. So you get the list here, you get the affected artifact, where that location is, where that package is installed, the artifact version that's impacted, and so on and so forth. And then we can move in and look, if we see any of those images in our cluster, right? So I can come in here and you can see the cluster state. You're able to come into the vulnerabilities tab, and you're able to query for that CV. So for the purposes of this walkthrough, we'll just use the first disclosure. So we'll do 4428. So I could see that I'm not impacted across any of my clusters for this one specific CVE, right? So that's how you can kind of visualize, okay, have I been impacted based on what's been scanned? Maybe that's during your CI/CD process and you've embedded Anchore into your CIA and CD process, and you're using the policy enforcement mechanisms to be able to detect for a 0 day like this. And then you just want to validate and ensure that that 0 day is not impacting anything that's in runtime. So this is how you validate that in runtime. But it's important now that you have that codified that you need to be able to build that into a policy, right? So Anchore has a CISA policy bundle. So we make this bundle open and public for all users of Anchore, whether it be open source or enterprise. And it is the CISA published vulnerabilities list. So these are vulnerabilities that are known to CISA to be actively exploited. So this list was actually released about 3 or 4 weeks ago. And so it's very timely that they started to maintain an artifact like this, and very useful for our customers because now we can quickly, run that update, gather the CVEs that are published on this website. So I could go ahead and validate that the CVE has been added here. So I can see that CVE has been added with the necessary description. So you're going to get a full description of what that CVE actually describes. So here we're talking about the Log4j vulnerability, and then how we have that stop action automatically gated for you. So that way, if you include this in your CI/CD process, none of the software your developers build will be able to pass if they're using Log4j in that. So that's a very, very useful feature, and you're able to do other things within here as well. So you could come in and specify the specific package of Log4j you would want to block list. So you could come in here and specify Log4j core, and then you could say something like 14.1 and stop that as well. So you could there's multiple different ways you could go about blocking the use of Log4j within your environments, and then codifying that as policy and making that an automated and repeatable process. So that way your developers don't have to worry about being able to detect that. Anchor will do the detection for you, and then we'll provide that additional coverage that isn't available in Sift and Gripe to go ahead and validate that there aren't those CVEs available in the runtime context, and it will be able to provide that automated policy function that isn't available in Sift and Gripe. So you could go ahead and use the automated enforcement mechanism within Anchor to stop those builds from progressing any further. Another really cool thing here, just to highlight a great capability when you're going in and triaging which images are actually susceptible to this vulnerability, you could go in our vulnerabilities tab and see if it's inherited from a base image. So in this case, it is not, but in some cases, you may notice that it is proliferating throughout your environment if it is being used widely in a base image, and if that base image is being used widely. So this feature right here, the inherited from base, is extremely useful in order to diagnose and triage the situation and see what images are exactly using the Log4j package. And similarly here, if we filter on the CISA bundles, we could see the Log4j CVE identifier here, and then we could see that this is actually not inherited from the base image, so this is good. So the image, at least that the parent image I built on top of didn't have this package, which means my developer has introduced this package. So that's it's a very useful feature in order to triage and understand the blast radius of the Log4j package within your system.